everyone and welcome to IB Methodology, your space for mastering IBDP mathematics with clarity and confidence. I am Pooja Chaudhary and in today's session we are going to explore one of the most fundamental concepts in IB math, that is functions. In this video, I'll be making you clear about what exactly are functions and what are its types and how to find the domain and range of the given function. So let's start with the topic. Let's start with what is a function. A function is a special kind of relation where each input has exactly one output. It means whatever value I am giving to my function as input, I will always get a single value as output. Let's take an example for getting more clarity. Fx is equals to 2x plus 3. Now, I will be putting few values of x and let's see whether it is a function or not. Let's say I am putting x value as minus 1. So, my output will be plus 1. Now, if I put my x value as 0, it means 2 into 0 plus 3. My answer will be 3. Now, if I put my x value as plus 1. So my answer is 5. It means for every different value of x, I am getting a different value of fx. So it is a function. Now let's understand functions through a mapping diagram. Let's take another example of fx is equals to 3x plus 1. Again, the first one will represent your x values and the second circle will give you fx values. Now let's put x as 0. So 3 into 0 plus 1 will be 1. Let's put x as 2. So 3 into 2 plus 1 will be 7. We can put x as 4. So 12 plus 1 will be 30. Now if you can see 0 is giving you 1, 2 is giving 7 and 4 is giving 30. From this we can say that it is a function and also is a relation. Check whether a given graph is a function or a relation by doing vertical line test. Now let's take some example for better understanding. In vertical line test, let's say only graphs are given to you instead of the equation. Then how we will proceed? So let's take first graph as A. Now if I draw vertical lines like this, you can draw as many lines as you want. It is cutting the function or the graph at only one point. It means it is a function. So your vertical line test says when you draw vertical lines and if they cut the graph at one point only, it means that graph or that function is a function, not a relation. This is also a function. Now let's move to the last one. If I draw vertical lines like these, you can draw as many lines as you want. And if you see, these vertical lines cut the graph at two different points. It states that for this single value of x, we are getting two values of y. So for one input, you are getting two outputs. Same for this and for this. It means it is not a function. Let's take some questions for practice. I am giving you these four graphs to perform the vertical line test and put your answer in the comment box. And if you have any query, you can email at the given ID below. Let's understand how to evaluate a function. We'll take an example. So we have to find the value of fx is equals to x square plus 5x minus 7. Find the value of f of 3. So let's see how we will proceed. I will replace my x value as 3. So 3 square plus 5 into 3 minus 7. 9 plus 15 minus 7. So my function value at 3 results in 70. Let's take another type of example. If fx is equals to x square minus 4x plus 9, then what is the value of x when fx is equals to 5? So what is the difference between these two examples? In the first example, we have to find the value of the function. And in the second example, function value is given to us. We have to find the value of x. So let's see how we will proceed. So fx is equals to 5. I will replace my fx as 5 and I will write the entire equation. Now I will be solving this equation by taking all the variables and constants to one side. So I am getting this as my quadratic equation. Now I have to factorize it. So I can factorize it like this, middle term splitting. So if I take x common, it will be like this. Now I can take my x minus 2 as common. So I am getting this. It means my x value is 2. So for x is equals to 2, my answer or my function value will be 5. So I can write that f of 2 is equals to 5. Now I am giving you a question for practice. If you have any query, you can post it in the comments. Just take this question. Now I will give you a hint in this question. Now this function is having two variables in this, x and y. And function value at 4 comma y means when my x value is 4, I don't have y value, my function value is 10. Then we have to find the value of y. Do give your answer in the comment box. Now let's move on to understanding the domain of the function. The first and the most important thing is what exactly is the domain. We have to understand this word properly. The key rule for finding domain of any function is never divide by 0 and never take square root of a negative number, because to find the domain of a function, your function should be real. We can only find domain of real function, and for the real function, if it is there in square root, it can never be negative. Now what exactly is domain? All possible values of x for which the function is defined, means whatever is our input, that is your domain. Let's study how to find the domain of a polynomial function. As you all know, there are different kinds of function. I will be covering few of them. One of them is polynomial function. For a polynomial function, if I take these four examples, these all are polynomial function in which the first one is my function of power 1. Second one is power 2, then power 3, and the last one is power 8. So it is a polynomial function. So what is important here to note is your polynomial function, all these functions have x belongs to R. R stands for real numbers. Real numbers. All these, because they all are real functions, so we can put any value of x in these polynomial functions. One is how to find domain of a rational function. Before going on to find domain, let's first understand what are rational functions. So rational functions are those functions which are in fraction form, let's say p by q form, where your q cannot be equals to 0. And this is the single rule for finding out the domain of a rational function, that your denominator or value of q cannot be equals to 0 for the function to remain real. Let's take an example of fx is equals to x plus 3 upon x minus 7. We will follow the same rule, as x minus 7 cannot be equals to 0. So I can say that x cannot be equals to 7. Now how we will write the domain of the function? Domain I will be representing by df. So domain of the function is x belongs to any real number r except 7. Or we can also write that x belongs to R and x cannot be equals to 7. Both answers are acceptable. Let's take another example of fx is equals to 2x plus 1 upon x square minus 16. Again we will be following the same rule. of x square minus 16 not equals to 0, x square is not equals to 16. So I can say that x cannot be equals to minus 4 and plus 4. So I will be writing the domain of the function as x belongs to R minus 4 and 4. It means all real values except minus 4 and 4. Or I can write x belongs to R but my x cannot be equals to minus 4 and 4. Let's see some more examples on rational function. The rule will remain the same. Let's take this example of x square upon x square plus 9. So we can write that x square minus 9 cannot be equals to 0. But what is important here to note is, since x is a squared number, so we can put any x value in the function, because it will never lead to an answer that will be equals to 0. So domain of the function, we can say that all values of x we can put, or we can write that x belongs to minus infinity to infinity with open brackets. Both are acceptable. Now let's take another example. X square minus 3x upon x square minus 8x plus 15. So in this, again x square minus 8x plus 15 is not equals to 0. Since it is a quadratic equation, we have to factorize this equation. I am using middle term splitting. From the first two terms I can take x common, and from the second two terms I can take minus 3 common. Again I can take x minus 5 common, so I am left with these two brackets. Now x minus 5 is not equals to 0, or x minus 3 is not equals to 0. From this I am getting that my x cannot be equals to 5, and from this x cannot be equals to 3. So I can write my domain of the function as x belongs to R except 3 and 5. And that's a wrap on today's topic function. In the next video, we will dive into graph of function using GDC, sign diagrams, how to transform a graph, how to find the inverse function using some real IB exam style questions. If this helped you, make sure you like, subscribe and drop a comment with your questions or topics you want to cover. From my side, thank you, and for any query, contact us on ibmathbypc@gmail.com. Do subscribe and like IB Methodology. Have a great day.